We'll be looking at two implementations of the queue data structure in this module, the first of which will use a linked list for the item storage. Now you may recall from the stack module that implementing a stack using a linked list was quite simple, but that the simplicity came at a performance trade-off. And the queue is no exception in this regard. To learn more about the specific issues I'm referring to, I would encourage you to go back to the stack module and look at the linked list implementation clips. Now we'll start by allocating a linked list. And items will be added into the linked list using the addLast method. Adding to the end of the list allows the items to be added in a consistent order, with each item falling into line behind the one that preceded it. And once we have the items in the list, we can see that the head of the list is also the head of the queue. Since we added items to the back of the list, it makes sense that it would remove or dequeue them from the front. This would use the remove first method on the linked list. And as you can see, each time we remove an item, the head pointer moves to the next item in the list, but the head of the list is always the head of the queue. Now you might be wondering, why add last and remove first? Why not add first and remove last? Well, it turns out there is a good reason. Like the stack, all of the items in the queue can be enumerated over. The expectation of the caller would be that the items would be enumerated in the same order that they would be dequeued. So in the example we just saw, we would expect the enumeration to have worked 1, 2, 3, 4, 5. So by storing them in the list, in the head to tail order, we can use the list to perform the enumeration for us. It just works. So now, let's go to Visual Studio and look at an implementation of a queue using a linked list.